polynomials. And as we get into polynomials, we've got, I think there's about 8 or 9 sections total within the polynomials. But one of the things that we are going to do is we will loop back into the quadratic stuff one more time at the very end of this. When we loop back to the quadratics, we're going to do some modeling. And when we do the modeling stuff with it, there's a lot of calculator, like quadratic regression, things like that, that we're going to look at in the calculators to write equations out. That process is the same thing when we do the polynomial regression stuff. So instead of having to teach it twice and how to do it in the calculator, we're just going to do it once and look at the 2 different scenarios. It just seems like we would save a day of instruction that way to do it that way. What's that? Captain Efficiency. So what I want to do today is go over, this is chapter 6 stuff in the book, and we're going to start with some exponent rules. Things that you have probably forgotten because you're teenagers and you forget things. So
can't even remember what I had for dinner last night.
So you can explain what you were doing. Thanks for getting there. I appreciate it. Tomorrow, yeah, same bad time, same bad channel. If maybe during class tomorrow, because it's only 1 question left, because we're going to enter in all those things in the lecture. So tomorrow, during that 5-10 minutes where it takes you to enter the lecture, I'll probably just take you Middle East. So let's.
Remind me of the rips of the Middle East.
Go there and trip on a joke about break the nose.
Don't even deny.
Oh, I'm sorry. Anywho, properties, exponents. See you, Christian. What I like to do is use this. What's 2 squared? 4.
9.
What's 2 cubed?
8.
2 to the 4.
Good question.
2 to the 5th.
32.
Okay.
You guys know
Because all you're doing is you're multiplying by 2 again.
Except like we're reading the video game, Jenna. Did you say like last week?
Let's go and do the other direction. What's 2 to the first power?
2.
Okay. What's 2 to the 0?
1.
1. One of the exponent rules that most people tend to forget. Anything to the 0 power is always 1. Okay?
But isn't there 1, 2?
The next one will help make this clear. Going to the negative exponent now. Very good. No.
Oh, it's 1 over 2.
No.
0.2.
1 over 2.
That's what it
You said they don't take
What if you have 0 to 0?
What would be 0 to the 0 power?
So would 2 to the negative 2 power
Okay, I just want to look up. I just want to look to I don't know that.
Think of it this way. Let me ask you this. Are you yourself?
Yeah.
Is there anybody like you?
Me.
7 people. Yeah.
Let's just say no. Okay? I was joking!
Get right.
Okay.
Now,
No 2.
it's not times no 2s.
2 with no 2.
Okay.
I need 2.
All right. What I want you to think of, I want you to think of it as an identity. There's nobody else like you, right?
It must be still.
I want you to think of it in terms of an identity. You are yourself. There's nothing else, nobody else like you at all. So only you can be you. You are the only one. Think of that. Nobody.
Unless you got a 1.
Now, what happens is you start going negatives. When you're working with negative exponents, like Clay said, you're working with reciprocals. A negative exponent is just an exponent that's unhappy. Like most of you in this class.
Yeah.
How did you know?
It's not my first day. Now, what happens here is, if you're not happy where you are, you normally want to leave, right?
Yes.
All of you want to get the heck out of here.
Yes.
Okay, so this exponent is unhappy where it's at. It's unhappy in the numerator. Where will that exponent be happy? In the denominator.
So the denominator is outside this classroom?
Yes. So what's happening here is you have these negative exponents. Negative exponents are nothing more than unhappy people. Anything to a negative exponent. Anything to a negative exponent, if that negative exponent occurs in the numerator, it isn't happy, so you make them happy, you put them in the denominator. Now it's happy, it changed spots. Yes, ma'am?
Why are you putting it in the denominator, like the exponent positive?
Because it's a reciprocal property is what it's called. It's changing the fraction here. Whereas also, one second ago, if I'm in the denominator, am I happy in my denominator?
No.
So I become happy in the numerator. Sir?
So you know how, like, when you're doing exponents like 2 to the 4th, you can just write 2 times 2 times 2 times 2. How would
Yes.
you write out this?
What happens is you have to write it 1 over it. It's the, like Clay said, it's a reciprocal property. The negative exponent creates a fraction.
Okay.
Okay. So what we're looking at here are some properties of exponents, some things that you have forgotten. For example, this is the one that most people forget. This is the one that most people screw up. Negative exponents are just unhappy. Make them happy. Change their denominator or numerator. Okay? Send them to their happy place. What? I know. It's the dumbest way in the world of presenting it, but you're not going to forget it now.
Numbers don't have feelings.
We all have feelings. Stop being a pessimist.
Numbers don't have feelings. They don't.
Which leads us to remembering properties.
Oh my gosh.
Now, for the most part, guys, come on. I don't want to talk over you, okay? For the most part, you guys have all done this before. It's just a matter of remembering it. Now, this first one is, let me define things here real quick. This A is a base, okay? The M and the N is an exponent. Bases and exponents. You guys have all heard those terms before, right?
Yes.
Okay. So when you're multiplying two things together that have the same base but different exponents, all you're doing is adding the exponents. For example, if I have x to the 4th times x to the 3rd, isn't x to the 4th the same thing as saying x times x times x times x?
Yes.
And x to the 3rd is? Isn't it that just that? If I wrote it out long form, how many x's are there? So it's x to the 7. All I do is add the exponents. Yes, sir?
What makes it different than x times x times x times x? And then if it's times x to the 3rd, wouldn't it be like the quantity x times?
You're mixing properties together. There's another
No, I
problem.
just don't get how that doesn't combine itself like that.
I'll show you in a second, because I've got something coming up like that, okay? I'll show you in a second, all right? Remember, if you have the same base, different exponents, add them together, okay? What Clay's worried about is power to power. If you already have something that has an exponent, it's being raised to another exponent, you multiply them. In his example, what he's thinking here is something like this. If I have x squared to the 4th power. X squared to the 4th power is the same thing as saying x squared times x squared times x squared times x squared. Do you agree? Yes. 2, 2, 2, and 2. Repeated addition is multiplication. So what you're doing here, instead of writing that out 4 separate times and then adding your exponents together, you're using the properties of multiplication, which is nothing more than repeated addition. All right? So this is just x to the 8. When you have power to power, you multiply. Okay?
Oh, it makes sense.
Why would that make sense?
Distance is a little bit shorter here. It takes a little bit more
That
time.
makes sense.
Just messing with you. In this one, it's a little bit different. See how you've got two things in the parentheses raised to the same power? You're distributing that exponent to both terms within the parentheses. That's what that looks like. Think of this one as distributive property of exponents, because that's really all it is. So if you have x, y, quantity to the third power, that's xy times xy times xy. But in other words, you're distributing that cube root, or cube root, that cube term to all. Okay. Yes, ma'am.
Can I just ask, like, why will we be using these properties, like, to find what will we be using these?
When we get into polynomials, this stuff comes up with polynomials. This is kind of a little refresher before we get into the big junk of polynomial rules and stuff, okay? Because a lot of these things you'll be doing some factoring and stuff like that, and finding zeros and all that stuff. So. Okay. Then we get into the negative exponents, just like I talked about a second ago. Anytime you have anything that's negative, they're not happy. We don't like to associate with negative people. So we want to associate with negative numbers.
You looked at me. Oh, between the frown
You're
and
supposed to see
upside down.
that.
I got it. I'm absurd. Flip the frown upside down.
Right. So again, if you've got x to the negative 4, oh, I'm not. Just saying.
A bully. Good.
I can't do this door.
Oh, shucks. Is that x happy? Is that exponent happy? Where will this exponent be happy? Under the denominator. So we just rewrite it as 1 over x to the 4th. Okay. And remember, it means the same thing if the exponent was negative in the denominator. Make them happy by sending them up.
Why does A not have to be 0?
Can you divide by 0? That's right. The only reason they put this caveat in here is because you can't divide by 0. That's all. You see that all the time. I don't normally do anything like that. Once again, anything that's raised to the 0 power, 1. They throw in the thing 0. You can't do 0, but I think they show that it does.
Why does that rule?
Because you are you.
Because you are you. It's an identity.
There's no one.
Yeah, it's like
You don't know.
it's an identity property. When we get to
You were born there.
all right, when we get into logarithms, I'll explain. It's a little bit easier to explain.
Because, like, A to the second power is like A times A. So A to the 0th power, never mind. A to the 1 power would bring
When we get into logarithms, it's very easy to explain why it works with logarithm. So hold that for about 3 weeks.
That's like a lot.
3 weeks.
I know, you'll forget about it. Now, this next one, I don't like to use what they show here in the book. When you have the same base and different exponents while you're dividing, I will. When you have the same base when you have different exponents and you're dividing, they always say take the numerator's exponent and subtract the bottom one. I like to do it a little bit differently. I like to play the game of war.
Oh, I remember this.
Now, if I'm looking at this, I have x to the 7th over x cubed. Who wins the game of war? A 7 or a 3? 7. So what's 7 minus 3? So since the 7 was larger in the numerator, the x values stay in the numerator. Okay? If you wrote this out in terms of long form, isn't this the same thing as, let's see, 1, 2, 3, 4, 5, 6, 7. What drops out? How many x's are left? Where are they? They're on the numerator. Okay? You're playing the game of war. Who wins? Works the exact same way if you have it as, let's see, z to the 3rd over z to the 10th. Who wins that battle of war? The 10. So what's 10 minus 3? What am I numerator now? 1. Does that make sense?
Yeah.
It's a little bit different than what the book shows. When the book does this, they just write it out in terms of numerator's exponent minus denominator. If I did it with this, it would be z to the 3 minus 10, which is z to the negative 7th, which is 1 over z to the 7th. It just takes too many steps. Play the game of war. Who wins? Subtract it out. It's quicker that way. Okay? Okay? And then the last property that was in here works with the fractions raised to exponents. Whenever you have a fractional amount raised to an exponent, let's say it's x over y squared. Once again, you are distributing that exponent to both the numerator and the denominator. Okay? Yes. Okay.
So b equals 0 to b can.
Yes, because can you divide by 0?
No, but you're allowed to 0.
It's a numerator.
I do.
The numerator? Making up words! Yay! The numerator! Okay? So, what's happening here again, they're just putting the caveats that you can't divide by 0. That's why they have that stuff written. Okay?
Yeah.
Now, the fun part. It's not just one step that they work with these. They mix them all together. Okay? Yes, ma'am?
No, I wasn't stopped.
Oh. You all right? I know you were right sometime. Okay, so I was stalling. Oh, by the way, I'm never going to give you number ones to work on because what could you do?
Calculator.
Calculator does it for you automatically. You put things in a fraction bar with parentheses around it and you make it look exactly the way these things are written, it spits out the right answer. There's no point in me telling you this. So let's do the fun ones.
Oh, yeah.
Take 5-6 minutes and try those.
Okay.
All of them?
Yeah, that's few, that's fine. Hopefully x cubed times x squared got you x to the 5th.
Yes.
Yay! Oh dear, someone's like,
Bad start.
all right, play the game of war. Who wins, a 3 or a 5? So, what's your answer?
2 over y squared. What?
2 over y squared. Now, for those of you guys that use slashy fractions,
Don't
do it.
You
Stop.
Stop.
Stop with the slashy fractions.
They don't want you.
Now, the quantity 3x squared, what do you get?
9x squared.
9x squared, good. The quantity y over 2 cubed.
Y squared over 8.
Well, it'd be y cubed over 8, but that's close enough.
Wait, really? On the test? It would be?
No, it wouldn't be. You'd mark it wrong. It's y cubed over 8, so, all right. 4x cubed all to the 4th power.
256x 12.
256x to the 12th?
Yes.
We good?
Yes. Why is 12?
Remember, this is 4 to the 4th, and then x cubed to the 4th. This is when you start mixing the properties together. 4 to the 4th is 256. Power to power is x to the 12th. Okay? Is it C's?
You might want to erase that now.
I will. We get into 15. X to the 0.
It's 1 over y squared.
1 over y squared. Very good. 1 over y squared. Okay. Now the last group. Let me move these down so I can get them a better, cleaner page.
This is where you didn't do good.
So, suggestion. I've made this point a couple of times today with the other classes, is that whenever you're dealing with these types of problems that have the funky exponent rules and all you have to redo, take a minute and rewrite everything. What I mean by that is to rewrite all of your numbers first, rewrite all of your variables to have positive exponents, then simplify, okay? Take a few seconds to do that. It's an extra step. Here I have 5 over 2. I can't do anything with it. X squared is positive, y is positive. Now I go down here. X to the negative 1. He's not happy. Click your eraser, where will he be happy? And then it's just y cubed. Okay? Now I'm going to rewrite it all. Everybody okay with that? All right. X squared times x, what do I get? So it's 5 halves x cubed. Then I have a y over y cubed. Y squared.
I squared the bottom.
And I'm done. Trust me, the stuff you're going to see later on has a ton of negative values, a ton of negative exponents. Rewrite them prior to doing anything. It'll make your lives easier. Yes, ma'am?
You don't have to do anything with the 5 and 2.
Nope. Nope.
It wouldn't be 3. So,
No, it's not. It's 5 divided by 2. No, here, you're done, okay?
I didn't do it.
Do you need to stand for a while? Yes, you may stand if you have to.
I'll take it.
Sitting is from Trump. How do you do that?
Don't worry about it. Careful, okay? Next one here. Take care of your numbers first. Just regroup them. -3 over 9. X, Y, those guys were both positive. X cubed was positive. The y to the -4th was not positive. Where will he be positive? Up top. So you just rewrite it up top now. Now, -3. It's just -3. It's not 3 to the negative power. So what's -3 over 9? -1/3. So I'm going to rewrite this as -1/3. Sometimes people just leave the negative up there. It's fine. Okay. X over x cubed. What do you get? Where? Good. And now I have y times y to the 4th. And it stays up top. Okay? Last one. Does everybody, we already had one like this where it's quantity 3x all squared, so that became 9x squared over 6x to the 5th. 3 over 2. Took care of my numbers first. 2 and a 5, who wins?
5.
What's 5 minus 2? Hopefully 5 minus 2 is still 3. I think it is.
Maybe. It might.
Okay.
Mr. Murphy?
Yes, sir.
So when we work with numbers this year, will we like not use numbers at all, we'll just use like only variables?
Oh no, we're going to do lots of numbers, my friend. We're just starting with
Will
this.
the final answer have variables and stuff in it?
No, we'll have zeros and we're going to have x's and y's. We got a lot of, you guys are going to see something really cool here real soon. As I pull it in, you're going to see synthetic division. Oh, yay.
heard about this. I heard especially it's really hard.
It's not that bad.
That's what they all say.
Sounds like if you only synthesize music on the keyboard.
I know you're super shy.
It's like a Herbie Hancock there. Plays Axel F.
I don't know the name of the song.
When you rewrite them with positive exponents, that first one goes to the bottom. This one stays up top. The x stays down there. The y goes up top. Oops. You get y cubed over x squared. Everybody got that?
Yep.
Yeah.
All right. The other ones.
These ones were
Rewrite the numbers first. So you have 5 over 20. X cubed, y to the 9th. X squared is the same. This y to the -2 goes up top. It becomes y squared. Now simplify your numbers. 5 over 20 is 1/4. So we have 1/4. X over x, or excuse me, x cubed over x squared is plain old boring.
X.
X up top. Y to the 9th, y squared becomes? Very good. Now, did I have to have that 1 there? No. If you leave there, it's perfectly fine. A lot of times with these things, there is going to be more than one way to write out the correct answer. They're all fine. And then lastly, rewrite your numbers first. When you rewrite your numbers first, you get -7 over 3 times 21. X, y to the 9th, y. This y is negative, so we're going to write him up top. and then this x to the 5th stays there. All I did there was just move all my numbers together and rewrote all of my exponents to be positive and kind of group them closely. Now, simplify your numbers. 7 goes into 21 how many times? 3. So this becomes -1 over 9. We have x and an x to the 5th. Who wins? So what does it become?
X to the 4th.
X to the 4th in the denominator. And now I have y to the 9th, y, and y squared. What do I get? Very good. And you're done. Okay? What were, wait, what? 9 plus 1 plus 2? Stop it. Here's what I want you guys to do tonight. What we're doing tonight is you're going to do some of these. I've got 9 of these to do.
Do we have to memorize
You better know. I mean, you should know. So what I want to do here, ladies and gentlemen, I want you to do numbers 7 through 15. Okay? You probably need a second piece of paper to do them on because there's no room. Okay? Do 7 through 15. If you want, that's fine. But what might happen when you write it going from forward to back, you might miss a value. That way you get a second sheet of paper, you won't screw up. Tomorrow when we come into class then, I'm going to have you guys enter in your solutions.
Oh wait, is this like the 8th grade?
We're going to enter you guys into the, I'm going to have you guys enter them into the clickers. All right? So when we come into class tomorrow, I'm going to have the clickers for you guys to go, which means you have to know your login number. I have created for you guys a generic login number, and I'd like you to put it in your agendas, that way you always have it. The question sets that I have here is I just cut and pasted the questions to go into the clicker. Number 7 is question 1, number 8 would be question 2, and so on and so forth. The clickers that I have that you probably have never used before allow you to write things as fractions and with exponents. It's a very complex clicker. It's pretty sweet. So when we get into this, you'll be able to type this question into the clicker without even seeing it, without seeing the question. Then we'll check everybody's answers at the same time. Okay? So let me give you guys some of your numbers. So give me a second here. Please, please, please write this down.